MySQL got you here. Simple, fast, everywhere. But you've hit the ceiling. Window functions you can't trust. JSON that's slower than it should be. Group by rules from 1995. No transactional DDL. And Oracle owns the roadmap. 5 numbers. 60 to 80% of your queries port as is. 10 times faster job search. Over 1,000 extensions. Number 1 most admired database, 4 years running. 0 Oracle license fees. I'm Dr. Ibrar Ahmed. Today, the complete MySQL to PostgreSQL playbook. 40 slides, every conversion, every gotcha, every fix. If you're a developer, DBA, or engineering lead, bookmark this video. You'll come back to it. 3 reasons you migrate. 1. SQL standard, real window functions, recursive CTEs. Merge, returning, lateral joins. Grouping sets, cube, rollup. MySQL has none of these or partial support. 2. Power features. Job with GIN indexing, 10 times faster than MySQL JSON. PostgreSQL, gold standard for geospatial. Built-in full-text search, custom types, 1,000+ extensions. 3. Reliability. True MVCC. Transactional DDL. Yes, you can roll back a create table. Logical replication. Community governed. No Oracle license surprises. And the good news. MySQL to PostgreSQL is easier than Oracle to PostgreSQL. Both open source. Both MVCC. Expect 60 to 80% of queries to port with minimal changes. Architecture. The biggest shift first. MySQL has pluggable storage engines, InnoDB, MyISAM, memory. PostgreSQL has one unified engine. Everything is a heap table with MVCC. Simpler. Database equals schema in MySQL, no namespaces. PostgreSQL, one database, multiple schemas, search_path resolves. Connection model. MySQL uses threads, cheap, lightweight. PostgreSQL uses OS processes, heavier, you must pool. This is the number 1 operational surprise for MySQL DBAs. We cover PG Bouncer on slide 25. Character sets. MySQL's UTF-8 is 3 bytes. Not real UTF-8. You need UTF-8 MB4. PostgreSQL is always real 4-byte UTF-8. No confusion. No mistakes. Every MySQL type, every PostgreSQL equivalent, 20 rows. Tiniant becomes smallint. Tiniant1 becomes Boolean. PG Loader does this automatically. INT becomes integer. Here's the trap. INT unsigned has no PostgreSQL equivalent. Unsigned integers do not exist in PG. INT unsigned must become big int. Bigint unsigned must become numeric 20. Double becomes double precision. Decimal maps to numeric, exact match. Varchar maps to varchar. Text maps to text. Medium text and long text all become text. No size variance needed. The critical one. Datetime maps to timestamp. But MySQL timestamp, which auto-converts to UTC, must map to timestamps, not timestamp. Get that wrong, and your time zone data is silently corrupted. Enum becomes a separate create type. Set becomes an array. JSON, always use job. The query level changes you'll make 100 times. Backtick quoting becomes double quote, or just lowercase everything. Limit 10, 20, MySQL's offset syntax becomes limit 20 offset 10. Standard SQL. If null becomes coalesce. IF condition becomes case when. Concat works in both, but PostgreSQL also gives you the double pipe operator, cleaner. On duplicate key update becomes on conflict do update, and you must name the conflict target. Group by with non-aggregated columns. MySQL allows it with only _full_group_by off. PostgreSQL always enforces the standard. Add every selected column to group by. Show tables becomes \DT in PSQL. Describe becomes \D. Muscle memory takes a week. Auto_increment. 3 PostgreSQL replacements. Serial, the legacy way, creates a hidden sequence. Generated always AS identity, the modern SQL standard way. Recommended, in the upgrade, returning. In MySQL you call last_insert_ID after an insert. Race condition risk every time. In PostgreSQL, insert into orders values something returning ID. Atomic, one statement, no race. Use returning on every insert and update. One of the best features you gain. Stored procedures. The delimiter hack goes away. MySQL needs delimiter / because semicolons confuse the parser. PostgreSQL uses $quoting, $sign. No delimiter. No confusion. Out parameters become function return values, much cleaner. Set variable becomes : assignment. Session variables with @ sign do not exist. Use return values or temp tables. The body logic translates almost directly. If, while, for, case, all the same. The syntax wrapper is different. The logic inside is 90% identical. Triggers split into two parts. A trigger function that returns trigger, and a create trigger that attaches it. The function must return new for before insert or update triggers. Return null, and the operation silently cancels. That catches everyone. One function, reusable across tables. PostgreSQL also gives you truncate triggers, multiple triggers per event, built-in variables like tg_table_name and tg_op. More powerful. But the two-step pattern is the mental model you must internalize. String functions. Most map directly. Concat, concat_ws, replace, lpad, rpd, substring, identical. The one that breaks everything, group_concat. It becomes string_ag with an explicit delimiter. Group_concat column becomes string_ag column comma. If you used order by inside group_concat, move it inside string_ag. Locate becomes position. Regex becomes the tilde operator. Hex and unhex become encode and decode with bytecode casting. Search your codebase for group_concat first. It's in every MySQL application. Dates. The format strings are completely different. MySQL date_format uses %y%n%d. PostgreSQL to_char uses yymmdd. No percent signs. Datediff does not exist. Subtract two dates, you get an integer of days. Unix_timestamp becomes extract epoch from now. Date_add with interval becomes just plus interval. Simpler actually. Year of column becomes extract year. Now and curdate work the same. Mechanical, tedious, straightforward. JSON. This is where PostgreSQL dominates. MySQL stores JSON as text. PostgreSQL has JSON, binary storage. The containment operator @, with a GIN index searches all paths at once. MySQL, create a generated column, index it, query the generated column. PostgreSQL, create one GIN index, query with @ or arrow operators. Orders of magnitude faster. Plus, JSON path queries, the SQL JSON standard. If you use JSON heavily, this alone justifies the migration. Indexes. B-tree, unique, standard, all map directly. Full text becomes GIN on vector. We cover that on slide 34. Spatial becomes gist with PostGIS. Prefix indexes, key column 10, become expression indexes with the left function. Here's what you gain. GIN for arrays, JSON, full text. MySQL has nothing equivalent. BRIN for huge time series tables, 1,000th the size of a B-tree. Partial indexes, index only rows where active equals true. Covering indexes with include, index only scans without bloating the key. After migration, review your indexes for these. Game changers. Views convert directly, same syntax. The upgrade, materialized views. MySQL doesn't have them. You'd build cache tables manually. PostgreSQL, create materialized view, then refresh materialized view concurrently, no locks on readers. Use pg_cron to schedule refreshes. Recursive CTEs, with recursive, let you traverse trees and graphs. Parent to child, any depth, one query. MySQL 8 added basic CTEs. PostgreSQLs are more mature and better optimized. Partitioning syntax differs significantly. MySQL defines partitions inline with the create table. PostgreSQL uses declarative syntax, create the parent, then create each partition separately with for values. The primary key must include the partition key in both. MySQL key partitioning has no equivalent, convert to hash. MySQL partition by range of year of column uses an expression. PostgreSQL only allows column references for range partitioning. Partition directly on the timestamp column. PostgreSQL gives you detach partition for zero downtime partition management. Default partitions catch overflow. The user model is fundamentally different. MySQL, users are name at host. Create user app at 10.0.0%. Host-based access is in the SQL. PostgreSQL, roles with login attribute. Host-based access lives in pg_hba.sonf, a separate config file. You must configure pg_hb.sonf for network access. MySQL grants on mydb.star become grant on all tables and schema, and add alter default privileges to cover future tables. Otherwise, new tables won't inherit permissions. This catches every team. Character sets. MySQL's biggest gotcha. MySQL's UTF-8 is not real UTF-8. It's 3 bytes maximum. No emoji. No many CJK characters. You need UTF-8 MB4 for real UTF-8. And MySQL allows different char sets per column, per table, per database. A nightmare. PostgreSQL. Encoding is set once at create database. UTF-8. Always. No UTF-8 versus UTF-8 MB for confusion. Before migration, show create table on every MySQL table. If anything uses Latin 1 or MySQL UTF-8, convert to UTF-8 MB for before migrating. Otherwise, encoding errors. Storage engines. InnoDB, the default, maps directly to PostgreSQL's default. Both MVCC, both row-level locking, both foreign keys. MyISAM, convert to InnoDB before migration. Run alter table engine equals InnoDB on every MyISAM table. MyISAM has no transactions, no crash recovery. PostgreSQL has no equivalent. Memory tables become unlogged tables, fast, but lost on crash. CSV engine becomes the file_FDW extension. Federated becomes Postgres_FDW, actually more powerful. Every migration follows 7 phases. Assess, audit your schema, stored programs, engine types, char sets. Convert, translate DDL, types, procedures, triggers, rewrite MySQL specific SQL. Migrate, choose your tool, move schema and data. Validate, row counts, checksums, query comparison. Tune, PostgreSQL.conf, PG bouncer, explain analyze, index review. Cutover, rehearsed, timed, rollback ready. Operate, monitoring, backups, replication, auto vacuum. The roadmap marker at the top of every slide tells you which phase you're in. Use it to navigate. PG Loader, the fastest MySQL to PostgreSQL tool. One command, loader MySQL://source, PostgreSQL://target. Done. Schema and data in one shot. For production, write a .load config file. Cast rules override type mapping, tinyInt to Boolean, int with auto_increment to serial. Excluding filters out temp tables. Workers and concurrency control parallelism. PG Loader handles 80% automatically. tinyInt1 to Boolean, enum creation, index recreation, sequence reset. What it does not handle: stored procedures, triggers, views logic. Those are manual. Use PG Loader for data. Manual conversion for code. 3 tools. 3 use cases. PG Loader, best for databases under 500 gigabytes when you can tolerate brief downtime. One shot, simple, fast. AWS DMS, best for databases over 500 gigabytes or when you need zero downtime cutover. Full load plus change data capture. Streams bin log changes in real time. Pair with AWS Schema Conversion Tool for DDL. Manual MySQL dump plus PSQL, only for small databases under 10 gigabytes. Maximum control, maximum effort, decision matrix. Under 10 gigs simple schema, PG Loader one-liner. 10 to 500 gigs, PG Loader with config file. Over 500 gigs or zero downtime, AWS DMS. 15 DDL patterns to convert. Engine equals InnoDB, remove. Default char set, remove, its database level. Auto_increment, generated always as identity. INT and signed, big int, tinyInt1, Boolean, datetime, timestamp. Timestamp, timestamps. Enum, 2-step, create type then use it. Set, text array. On update current_timestamp. Trigger function, covered next slide. Comment on column, separate DDL. Zero fill, to_char, or pad at display. Insert ignore, on conflict do nothing. Replace into, on conflict do update. Print this slide. The number 1 MySQL feature people miss. On update current_timestamp. MySQL, add it to a column and the timestamp auto updates on every update. Built-in. No code. PostgreSQL doesn't have it. You need a trigger function. Create set_updated_at. One function that sets new.updated_at to now and returns new. Create it once. Then attach it to every table that needs auto-update timestamps with create trigger before update execute function set_updated_at. Search your MySQL dump for on update current_timestamp. Every table that has it needs this trigger. Validation is non-negotiable. 10 checks. 1. Row counts match for every table. Not estimated. Exact select count star. 2. Null counts match. 3. MIN, max, sum on numeric columns match. 4. Foreign keys valid, no orphans. 5. Sequences reset to max ID +1. 6. Indexes exist and are valid. 7. Constraints enabled and enforced. 8. Application queries produce identical results. 9. Edge cases. Empty strings versus nulls, date boundaries. 10. Performance. Key queries within SLA using explain analyze. Run analyze first. Without it, the planner has no statistics and plans will be terrible. Map your MySQL tuning knowledge. InnoDib_buffer_pool_size becomes shared underscore buffers, set to 25% of RAM. Not more than 40. InnoDib_size becomes max_size, 2 to 4 gigabytes. Sort_buffer_size becomes work_em, but careful. Work_mem is per operation, not per connection. A query with 5 sorts uses 5 times work_mem. With 100 connections, that adds up fast. Start at 64 megabytes. Query_cache_size. PostgreSQL has no query cache. Use Redis or the application layer. The 2 MySQL doesn't have effective_cache_size, set to 75% of RAM, tells the planner what to expect from OS cache. Random_page_cost, set to 1.1 for SSD. Default 4.0 is for spinning disks. Huge impact on query plans. The operational change that catches every MySQL DBA. MySQL, 1 thread per connection. 256 kilobytes overhead. PostgreSQL, 1 OS process per connection. 5 to 10 megabytes overhead. 1,000 MySQL connections, 250 megabytes. 1,000 PostgreSQL connections, 10 gigabytes. You will run PG Bouncer. Transaction mode. 25 server connections for 2,000 app connections. Install it day 1, not day 2. Not after the first out-of-memory error. Day 1. Query analysis. MySQL explain gives you a flat table, type, rows, extra, limited. PostgreSQL explain analyze buffers gives you the actual execution tree. Every node's actual time versus estimated rows. Buffer cache hits versus disk reads. Planning time versus execution time. Paste the output into explain.dollybo.com for a visual tree. Always use analyze and buffers together. Explain without analyze is estimated only. With buffers, you see if the query is hitting cache or going to disk. That's the difference between finding the problem in 2 minutes and guessing for 2 hours. Auto vacuum. No MySQL equivalent. MySQL's InnoDB purge thread runs silently. PostgreSQL's auto vacuum does the same job, cleans dead tuples left by MVCC, but it must be monitored and tuned. Default scale_factor is 0.2. 20% dead rows before vacuum kicks in. Too lazy for hot tables. Set it to 0.05. 5%. For your busiest tables, use per table overrides. Alter table orders set auto vacuum_factor equals 0.01. Monitor in_top and page_static user_tables. If it grows, auto vacuum is falling behind. And never disable auto vacuum. Transaction ID wraparound will make your database read-only. Cutover. T-2 weeks. Rehearse on staging. Time every step. T-1 day. Full PG loader load. If using DMS, start CDC replication. T0 minute 0. Stop application writes to MySQL. Wait for CDC lag to hit 0. T0 minute 5. Verify checksums on critical tables. Run smoke test queries. T0 minute 15. Update connection strings. DNS switch, health check, monitor error rates. T0 minute 30. If errors exceed threshold, revert DNS to MySQL. MySQL was frozen, data is consistent. Keep MySQL alive for 48 hours after cutover. The rollback drill is not optional. Practice it. Backup. MySQL dump becomes PG_dump. Percona extra backup becomes PG_base backup, built into PostgreSQL core. For production, use PG backrest, incremental, parallel, S3 support, point-in-time recovery. Enable WAL archiving for continuous backup. Minimum strategy, daily PG_base backup. Continuous WAL archiving to S3. PG backrest for automation. Monthly restore drills. A backup you have not restored is not a backup. Replication. MySQL binlog replication maps to PostgreSQL WAL streaming. Functionally equivalent. Semi-synchronous maps to synchronous_commit. The upgrade. Logical replication. Built-in publication and subscription. Subscribe to specific tables. Filter rows. Replicate across major versions. This enables zero downtime major version upgrades, something MySQL makes much harder. For failover, Patroni plus ECT is the industry standard. Automatic leader election. Automatic promotion. Monitoring. Show process list becomes PG_stat_activity. More detail. Performance schema becomes PG_stat_statements, the number 1 tuning extension. Enable it immediately. Add it to shared underscore preload underscore libraries and restart. Slow underscore core underscore log becomes log underscore min underscore duration underscore statement. Set to 200 milliseconds. Show table status becomes pg underscore static user underscore tables, dead tuples, last auto vacuum, sequential scans versus index scans. NODB buffer pool hit ratio becomes a simple calculation from pg underscore stat underscore grider. Target 99% cache hit ratio. The exact errors your application throws on day one. Column capital N name does not exist. PostgreSQL folds unquoted identifiers to lowercase. Use double quotes or rename. Operator does not exist and equals varchar. MySQL auto casts. PostgreSQL doesn't. Add explicit casts. Column not in group by. Add every non-aggregated column. Limit 10, 20 syntax error. Limit 20 offset 10. Function if null does not exist. Coalesce. Function group underscore concat does not exist. String underscore ag. Duplicate key violates unique constraint. Sequence out of sync. Fix with setval. Pin this slide. You'll hit at least 8 of these. Connection strings. MySQL :3306 becomes PostgreSQL :5432. Python. Misclient becomes Psycop2. Node. MySQL 2 becomes PG Java. JDBC MySQL becomes JDBC PostgreSQL. ORMs. Django. Change engine to Django.db. Backends. PostgreSQL. Rails. Adapter PostgreSQL. Laravel. DB underscore connection equals PGSQL. Most ORMs abstract the SQL differences, but raw SQL queries need manual review. Test Boolean handling. MySQL 0/1 becomes PostgreSQL true/false. Full text search. MySQL full text index with match against becomes PostgreSQL vector with the double add operator. Add its vector column with set weight for title versus body weighting. Create a GIN index. Search with to_its query. Rank with TS_rank. Highlight results with TS_headline. Language-aware stemming. PostgreSQL full text is production grade. Many teams remove Elasticsearch after migration. Built-in search is good enough. Extensions. Install these on every production server. Performance. PG_stat_ statements. Query stats. Non-negotiable. Auto_explain. Automatic explain for slow queries. PG_buffercake. Inspect shared buffers. PG_prewarm. Preload indexes after restart. Security. PG audit. Detailed audit logging. PCrypto. Encryption and gin_anim_UID. PG_TRGM. Trigram similarity. Fuzzy matching. Data. PG_cron. Replaces MySQL event scheduler. PostGIS. Geospatial. PVector. AI embedding search. Postgres_FDW. Connect to other PostgreSQL servers. 10 silent killers. 1. 0000 dates. MySQL allows them. PostgreSQL throws an error. Clean before migration. 2. Empty strings and not null columns. MySQL uses empty string where null was intended. Review your app logic. 3. Silent truncation. MySQL silently cuts varchar overflow. PostgreSQL throws an error. Check max lengths. 4. Case sensitivity. MySQL is case insensitive by default. PostgreSQL is case sensitive. Use Cytext extension or lower in queries. 5. Escaping. MySQL interprets \n as new line. PostgreSQL treats / as literal. Use ePrefix for escape sequences. 6 through 10. Boolean 0/1 versus true/false. Transactional DDL differences. Implicit commit behavior. In O_date mode. The first 4 cause 80% of post-migration bugs. What to expect? PostgreSQL is faster at complex queries. The optimizer is superior. Job operations. GIN index containment is 10 to 100 times faster. Full text search with ranking. Concurrent mixed workloads. Large aggregations with parallel query. Geospatial with PostGIS. Where it may need tuning. Simple point lookups at extreme scale. NODB clustered index can be marginally faster. Connection handling. PG bouncer is mandatory. Bulk inserts. Use the copy command. 5 to 10 times faster than insert. Table bloat. Configure auto vacuum properly. Bottom line. 80% of workloads match or beat MySQL out of the box. The remaining 20% needs PG bouncer, copy, and auto vacuum tuning. 20 items. Print this. Pre-migration. Audit storage engines. Convert to UTF-8 MB4. Find and sign columns. Inventory procedures and triggers. Search for MySQL-specific SQL. Conversion. Remove engine and char set. Add identity columns. Convert enum and set types. Rewrite procedures in PL/PGSQL. Add set_updated_ at triggers. Migration. Choose your tool. Run on staging first. Validate row counts and checksums. Verify sequences. Run your test suite. Production readiness. Install PG Bouncer. Tune PostgreSQL.snf. Enable PG_stat_ statements. Set up backups. Document the cutover plan with rollback. Screenshot this slide. 20 conversions in one table. Auto_increment to identity. Last_insert_id to returning. If null to coalesce. Group_concat to string_ag. Limit offset syntax. Date_format to char. Unix_timestamp to extract epoch. On duplicate key to on conflict. Insert ignore to on conflict do nothing. Show tables to \DT. Describe to \D. Delimiter to $quoting. Tiniant1 to boolean. JSON $key to jomb arrow key. Engine equals nodb to remove. On update current_timestamp to trigger. Tape this to your monitor. That's the playbook, 40 slides, every conversion. Every gotcha, every fix, now 3 things. Each takes 5 seconds. 1. Subscribe at youtube.com/@dribrarahmed. A new PostgreSQL deep dive every week. 2. Press the bell. Pick all notifications so you don't miss the next episode. 3. Comment the word migration below. I'll DM you the GitHub companion pack, pgloader config, validation SQL, cutover runbook, function mapping, the top 20 error fixes. Share this with your team before you start a real migration. I'm Dr. Ibrar Ahmed. See you in the next deep dive. Allah Hafiz.